Hello everyone and welcome to 30 days of DSA challenge, where we will be solving a DSA problem every day for the next 30 days. So this is our day number 13, where we will solve a problem based on hashing, and the level of this question is going to be easy. The name of this question is Two Sum. You will get this question link in description, and you can also download this Excel sheet from description. Now, without wasting much time, let's see our question on LeetCode. So this is our question on LeetCode. It says, given an array of integers, nums, and an integer target, return the indices of the two numbers such that they add up to target. The question says that we have been given an integer array or integer vector named as nums, and we have also given a integer variable named as target. Now we have to return the indexes, right? We have to return the indexes of the two numbers, right? We have to return the indexes of the two numbers which are present in this nums array. And when we add those numbers, we should get our target, right? We should get our target. Now you may assume that each input would have exactly one solution. So this line is very important. It says that for every input, we have exactly one solution. It means that we will not have any input for which we do not have a solution, and similarly we will not have any input for which we have more than one solution, right? For which we have more than one answer, right? I hope it is clear. And you may not use the same element twice, right? We cannot use a same element twice for calculating our sum, and you can return the answer in any order, right? And here are some of the sample test cases. So let's analyze this problem by taking some examples. So this is nothing but our nums array, correct? And this is the value of our target, which is equal to 9. So if we clearly see into this array, and if I ask you just give me two numbers, which when I add them, I should get my target, right? So you will say I can add 2 and 7 and I will get my target equal to 9, correct? But I have to return the indexes, right? I have to return the indexes. So the index of 2 is nothing but 0 and the index of 7 is nothing but 1, right? So I can either return this, I can either return 0 and 1, or I can also return 1 and 0, right? Because in the question it was clearly mentioned that we can return our answer in any particular order. Okay, so if we see this particular question, then the very first approach comes in our brain is to use two nested for loops to solve this problem. And now I'm not going to discuss that particular solution because we have already solved this problem with that particular approach in our day 1. So now we will think of a more better approach. We will solve this problem using hashing. We will solve this problem using HashMap. Okay, so but before approaching this problem, let me just explain you some basic stuff so that the solution will get very clear into your mind. So let's say we know that when I add this 2 and when I add this 7, I get my target equal to 9, right? So let's say this 2 is nothing, but let's assume it is A. Let's assume this 7 is nothing but B. And let's assume this 9 is nothing but our T, right? And if I'm adding A plus B, I'm getting the value target, right? I'm getting the value T, okay? Now, let's say that I know the value of A, right? Let's say that I know the value of A. I know the value of A. And I also know the value of target. But I don't know what is the value of B, right? This is our scenario where we know the value of A. We know the value of our target, but we don't know the value of B. Now, if I ask you, can you derive the value of B? You will say, yes, it is pretty easy. I can just write B is equal to T minus A, and it will give me the value of B. It will give me the value of B. Okay, cool. Now let's analyze this approach in this particular example in this sample test case. Okay, so let's say initially I am here at index number 0, and the value which is present at this index, let me call it as A, right? Let me call it as A. So I know the value of A, which is equal to my 2, correct? I also know the value of my target, it is equal to my 9, right? It is equal to 9. So I also know the value of target, it is equal to 9, right? But I don't know the value of b. So let me just write it as it is, right? Let me just write it as it is. I don't know the value of b, correct? Now if I ask you, if I have one number which is 2, right, and I want to add something to it to get my target equal to 9, right? Can you just derive what should be the value of this b to get my target equal to 9? Very easy. We will again use the same formula. B is equal to target minus a. So here the value of target is 9 and here the value of a is 2. So we will write 9 minus 2, which is equal to 7, It means that if I add 7 to this 2, I will get my target equal to 9, right? I will get my target equal to 9. So now I will try to see that did I visited this 7? Did I have seen this 7 somewhere in this my array? So right now, no, I haven't seen 7 because this was the first index, right? This was my first index. So now let me just go to the next index, which is index number 1. Okay. And let me just call it as a, right? Let me just call it as a. So the element which is present at index number 2, it is nothing but my 7, right? So I will say that I know the value of a, it is equal to 7. I know the value of target, it is equal to 9. But I have to search for a number. B. When I add this number b to my 7, I should get my target equal to 9, correct? Again, I will ask you, can we derive the value of 9? You will say yes, definitely. So we will use this particular formula, right? What is the value of target? Target is 9. What is the value of a? For this time, it is 7, right? It is 7. So 9 minus 7, it will give us 2, right? It will give us 2. So now it is very clear that if I add 2 to this 7, I will get my target equal to 9, right? So now I will again think of the same scenario, right? Did I have seen this 2 before, right? Did I have visited 2 before visiting this 7 in this particular array? So the answer is yes. Yes, we have indeed visited our 2, right? We have indeed visited our 2 at index number 0. So now I know that what I want to return the indexes. So I can directly return the index which is equal to 0, and I can also directly return the index where I'm currently standing, which is equal to 1, right? So if I return this 0 and 1, this will indeed be my answer, because if I add the element which is present at index number 2, that is 7, and if I add the element which is present at index number 1, which is 7, if I add them, I will get a value equal to 9, which is nothing but my target, right? So this is going to be our approach, right? But now the question arises, how I'll get to know that I have visited any particular number, or a particular element before, right? How I will get to know this? How I will remember that I have visited this particular number at a particular index? So this is the scenario. This is our requirement. Where we will use the concept of map, or you can say hash map, right? So what we will do, we will use a map where we will store two things. Firstly, the number, and secondly, the index where we have seen that particular number, right? So this is something which we are going to use, and now with the help of this map, we will surely solve this problem. Okay. So let's say we are iterating in this nums array. And initially our I is pointing at index number 0, right? Our I is pointing at index number 0. So we will again use the same method or the same formula. You can say that if I know a plus b is going to be equal to my target, and if I know the value of a, which is nothing but 2, if I know the value of target, which is nothing but my 9, and I don't know the value of b, so I just have to find out what should I add to this 2 so that I will get my target equal to 9, right? So I can directly find out by doing this. B is equal to target minus a, right? Which is nothing but b is equal to target minus nums of I, right? B is equal to target minus nums of I, and here the value of target is 9 and the nums of I is nothing but 2, so it will give us 7, right? It will give us 7. Now we will go to our map, right? We will go to our map and we will ask our map, do we have visited 7 before this particular index? So our map will check, our map will check, it will say no, currently the map is empty. It means that we haven't visited any element before this element, right? Before this index. So okay, if this is a scenario where we haven't visited any element, what we will do, we will just simply add this particular element and their index into our map, right? So we will write here 2 and the index 0, right? Now what does this map signifies, right? What does this this particular input in this map signifies? It signifies that we have seen this element 2 at the index number 0, right? This is something which is clear, right? Which is clear to you, I hope, right? Now my I will get incremented and now it will point at index number 1, right? Now it will point at index number 1. So again, I will try to find out the value of B, right? I will try to find out a value which if I add to this particular element, I got my target. I get my target, right? How I will get that? I will simply do this target minus nums of I, right? Target minus nums of I. So what is the value of my target? Value of target is my 9. And what is the nums of I? It is nothing but 7 itself. So it is 7. So if I do 9 minus 7, I will get 2, right? And this is the value of my B. Now I will again ask my map. I will again ask to my map, do we have visited 2 somewhere before this index, somewhere before this particular index? So my map will check and it will say, yes, we have visited this 2 at index number 0. At index number 0. So now once we found this particular value of B into our map, what we need? We just need to return the indexes, right? We just need to return this index, which is equal to my 0. And I want to return the other index, which will be equal to my I, where my I is pointing, right? So I will return these 2 indexes and this will be my answer, correct? So I hope this particular approach is clear to you. Now let's think about how we are going to code this approach. In order to solve this problem, what do we need? We need a map. So we will use one unordered map, right? Why we are using an unordered map? Very simple, because we know that in unordered map, the average time complexity for any operation is going to be O of 1 or constant, right? So this is the reason. And let me just name it as MP, right? Let me just name it as MP. And so after doing this, what we just simply want to traverse in this array, right? So I can probably write a for loop int I is equal to 0 up to n, where this n is nothing but the size of our nums array, right? Size of our nums array. So what we want, firstly, we want to calculate the value of B, right? What will be the value of B? B is going to be target minus nums of I, right? Target minus nums of I. And I will check, is this B is present into my map or not, right? So how I can do that? I will write mp dot find B, right? If it is not equal to mp dot end, if it is not equal to mp dot end, it means that this particular element B is present into my map, right? If it is present into my map, I just need to add it into my answer, right? So for returning the answer, I will also need one answer vector, right? I will also need one answer vector. So let me just create it. Okay. After that, what do I need? I just need the index, right? I just need the indexes. So I can just write answer dot push back map of B, right? Because this map of B will give me the index of the B, right? It will give me the index of this particular element, right? And after that, I can simply write answer dot push back the current index, which is equal to I, right? And after doing this, I can simply write a break, right? I can simply break from this loop. If this is not the case, then what we want? We just want to simply put our element and the respected index to our map, right? So we will directly write mp of nums of I equal to I, right? Okay. And after this for loop, I can just simply return my answer, right? I can just simply return my answer. So this is going to be our code. It is very easy. So if we talk about the space complexity, So this map will at max store all the element and all the indexes. So at max the space complexity will be O of n. And if we talk about this answer vector, then it is going to be of size 2 because it will only include 2 variables, 2 indexes. And if we talk about the space complexity, then it is going to be equal of O of n because we are running a for loop. And to put an element into an unordered map and to use the find method, the average time complexity of an unordered map is equal to O of 1. Therefore, this will be our time and space complexity. Now, without wasting much time, let's code it up on LeetCode. So here we are on LeetCode. So let's code it up fastly. So what do I need? I need one unordered map, right? So I'll write unordered map of type int and let me name it as MP. And after that, I will need one answer vector, right? Because here you can clearly see that I have to return a vector of integer type. Okay, after that, I just need to simply traverse into my nums array or nums vector. Okay, so what we will do, we'll try to find out the value of b, which will be equal to nothing but target minus nums of I, correct? And after this, we will try to find out this b is present into my map or not. I have visited this particular element or not before the index number I, right? So I will write if mp of b, sorry, I'll write mp dot find b if it is not equal to mp dot end, right? It simply means that if I have visited this b, right, if this b is present into my map or not. If it is present into my map, then I just need to store the indexes and just get out of this for loop, right? So I'll break it. So I will just write answer dot push back. I will write mp of b, right? Because it will give me, mp of b will give me the index of this particular element b, right? And secondly, I will just push back the present index, which is going to be my I. And after doing this, I will break this loop, right? I will come out of this loop. And if this is not the case, it means that if this b is not present into my map, if I have not visited b earlier, then what I'll do, I will just simply put the element which is present at this particular index and the index in my map, right? So I will write mp of nums of I equal to I, right? What it will store? It will store the element which is nothing but nums of I, and it will also store the corresponding index which is equal to I, right? Now after completing this for loop, I will just simply return my answer. So this is our code. Let me just run this. Okay, so here you can clearly see that all the 3 sample test cases are running fine. Let me submit this. Okay, so here you can clearly see that this particular solution is accepted, and I have already explained you the time and space complexities. So I hope you like this video. If this video was helpful to you, make sure that you liked this video, you comment if you are facing any issue or if you have any different approach for this particular problem, and make sure you subscribe to this channel so that you will get this type of content regularly. We will meet again tomorrow with a new question.